So we have seen BGP first chapter. We have learned that BGP is a border gateway protocol that is recommended routing protocol in the borders. IGP are the protocols that are recommended to use within the autonomous system. Both the routing protocol does route distribution, but BGP distributes networks that belong to different autonomous systems. BGP deals with the networks that coming from different autonomous system, going to different autonomous system, whereas IGP focuses on the networks that are within the autonomous system. That's the big difference. That's the big difference between BGP and IGP. And we also learned that BGP uses TCP. So whenever there is TCP, there is only unicast. So if someone is asking what multicast address BGP uses, BGP, you don't want multicast address. Answer is BGP never sends hello packets. BGP, no need a hello packet for BGP because the neighbors are not dynamically discovered in BGP. Because BGP is a TCP, connection oriented application layer protocol, we have to configure the neighbors manually. We need to configure the neighbors manually. If neighbors need to be configured manually, why there is need for hello packets? You tell me. There is no need for hello packets. There is no need for multicast address. See, OSPF needs multicast. Why? OSPF discovers the neighbor dynamically. It uses multicast address 224.0.0.9. No. 224.0.0.5. OSPF uses 224.0.0.5 to discover neighbor. We don't have such dynamic discovery of neighbor in BGP. In BGP, neighbors are manually configured. Right, let us now learn something very fundamental to BGP. I just said the neighbors need to be manually configured. For example, if this router's G0 interface is 10.1.1.1/24, if this interface address is 10.1.1.2/24, and let's say this two wants to form neighbor. So the autonomous system is here 10. The autonomous system here is 20. If this two needs to form neighbor, I told you we need to configure neighbor manually. So this is how we configure. On router 1, I'll say router BGP. What is the autonomous system number? See and tell. What is the autonomous system number of router 1? Okay, sorry, it is 10. Okay, I written like 16. It is 10. and then neighbor, the address of the neighbor. Tell me what is the address of the router 2? 10.1.1.2. Remote AS, that's the keyword that we should use, remote AS. See, these two are EBGP or IBGP. What I was trying to say is, whether it is EBGP or IBGP, the command is going to be remote AS. Remote means, how can it be IBGP? I'm telling you, that is how Cisco is. Even for IBGP, see, later we will be connecting a router 3 behind router 2. And router 3 and router 2 is going to be in same autonomous system. The command that we use to form neighbor even in IBGP is same. Then how router knows the difference between EBGP and IBGP? See, if I put 20 here, the local is 10. The neighbor is, this is neighbor, router 2's address. Neighbor is not in 10. That means EBGP. Next. That's all actually you need to configure. This is the configuration that goes on router 1. On router 2, we configure like this. This will be 20, and this will be 1, and this will be 10. Is this clear? Do you have any question? If you do this, the neighbor will come up. But just doing like this and seeing our neighbor has come up, finish, that is not enough. We need to understand how BGP works. In order to form neighbor, what all happens? I told you BGP is a TCP protocol. So what will happen, as soon as you say this, router 1 will send a sync packet, TCP sync packet for three-way handshake. The sync packet, the source address of the packet will be, you need to answer me, what will be the source address? R1 is sending the packet. What will be the source address? 10.1.1.1. Say, okay. What will be the destination? It will take the destination from the neighbor that you configured. So what will be the destination address? 10.1.2. To this address, with a source port number, random port number, let's say 5555, destination port number will be 179. Please pay attention, destination port number is 179 because it's BGP. Now this packet will go to router 2. When router 2 receives the packet, it will check whether the destination address and its own address matches. Is it matching or not? It is matching. Right? The destination address and its own address is matching. Now, it will open the fourth layer. In fourth layer, what it does, what it sees 179. Now, router 2 understands that, it is BGP's packet. By looking into 179, router 2 understands This is not an ICMP packet, this is not an FTP packet, this is a BGP packet. That's why we need port number. Fine. If it is BGP packet, then what it will do? It will check the source address in the neighbor list. The source address of the packet should be seen in the neighbor list. If yes, if it is seen, only then it will send SYN packet and then the acknowledgement for the SYN packet which came from R1 acknowledgement. If this address is not matching, let's say this is 10, the incoming is not matching. The incoming packet source address is not matching. In that case, it will not send SYN packet. It won't form three-way handshake. If three-way handshake is not happening, the neighbor won't come up. So what I'm coming to say is, first there was a SYN packet, synchronization packet sent from R1. R2 will check the source address with the neighbor list. If match is found, R2 will send its own SYN and acknowledgement. This acknowledgement is for this SYN, and this is R2 SYN, for which R1 now compares the source address of R2 packet. What will be the source address of R2 packet? R1 will check whether 10.1.1.2 matches with the neighbor statement. Yes, it matches. Then what happens? R1 will send an acknowledgement. This we call it as three-way handshake. See, only when your neighbors are properly configured on both sides, the three-way handshake will get complete. Otherwise, it will break in the middle and neighbor will never come up. If by mistake, if I give wrong IP address here, the incoming packet source will never match and three-way handshake will never pass. Only after three-way handshake. You remember we learned different type of messages. Only after three-way handshake, open message will be sent. In the open message, what you will see, I showed you in the previous class. I was teaching you in the previous class. What do you see in the open message? Router ID, autonomous system number, and the hold time. All these things are sent in open message. So, for example, if you have a loopback address here, that will be automatically taken as a router ID, like OSPF. Like OSPF, BGP also picks the loopback interface address as a router ID. So, router 1 will say, my router ID is 1.1.1.1. I am coming from autonomous system 10. The hold time is 180. What is the hold time? No, my dear. Hello time is, keep alive timer is 60 seconds. I told you in the previous class. Keep alive is sent every 60 seconds. If a neighbor is not sending keep alive for 180 seconds, a neighbor is considered dead. You understand? So this information will be shared in the open message. So after three-way handshake, the open message will be shared to and fro. After open message, if you are advertising some network from router 2 and router 1, those things will be shared as what? Update. In the update, you will see all the networks and their attached attributes. All the networks and the attached attributes. That is what called as update message. And then they establish the neighbor, So this is how BGP is going to form neighbor. You just put this command, but all these steps is carried out. In the update for every network, it will send the network plus attribute information that will be shared. So when a router receives it, they don't simply receive only small metric and network. It receives network and the attributes. Fine. So we are going to see now these things in the command line. Here you see I have 3 routers. I'm going to bring up those 3 routers. And we got the command line. Yep. So we got the command line. I can see the BGP is already configured. Let me remove those BGP. No router BGP 10. That's how we remove it. That's it. I'll also remove from router 2. Because in the previous batch I used the same topology. No router BGP 10. Sorry, 20. And router 2 BGP is 20. I'll also remove from router 3. Done. So between router 2 and 3 we are going to form Ibgp. Now let's configure. It's a fresh router with only IP address, IPBGP. So BGP is not available. Show IPBGP summary. This is the command to see the neighbors. There is no BGP neighbor. BGP is not active. Before I configure, I would like to right click and show you the capture in Wireshark. I want you to pay attention closely to this. As of now, there is no BGP packet, no TCP packet. Let me go and configure R1. Router BGP 10. You see in the diagram? Autonomous system is 10. Router 1 is an autonomous system 10. And I'm saying neighbor is 10.12.0.2. Remote AS is, can someone complete the statement? Remote AS is what? 20. Now, as soon as I say this, you will start seeing a packet coming from router 1. See, router 1 is sending a SYN packet. But there is no SYN acknowledgement. I told you, for SYN, there should be SYN acknowledgement. Instead of SYN acknowledgement, what it is saying, it says reset acknowledgement. Why you know? Router 2 is not configured. So router 2 is not sending SYN packet. It says, I don't know you. So it resets. So three-way handshake is not completing. Only when the three-way handshake is complete, open message can be sent. So far, do you see any BGP packet? No, only TCP packet you see. There is no BGP packet. Now, let me add something more. On R1, I'm going to have a loopback interface, which I want to advertise. Interface loopback 111, IP address 111.0.0.0 1. Mask is 255.255. Sorry. Mask is 255.0.0.0. So this is the loopback interface address. I just want to advertise this in BGP so that I can show you this network learned on R2 through this BGP update. Okay, so what I'll do, I'll advertise in BGP. Router BGP 10. How do you advertise? Not the neighbor command, you need to put network command. Network 11.1.0.0.0. Let me ask you a question. Is this classful or classless? Is the mask classful or classless? If it is classful, you no need to mention mask under BGP. In case if it is /24, what you should have done is, you should say mask 255. You should put the keyword also mask 255, 255, 2550. But in our case, you no need to say mask because it's going to be default. It will take automatically. Now, we are advertising this network, but will it get advertised to router 2? Will this get advertised to router 2? No. Why? Because router 2 is not neighbor yet. Router 2 is not a neighbor. We are not configured router 2. So BGP, first of all, it has to finish the three-way handshake. Only after that, only after open message sent on either side and confirmed, it will go to update, and then it will share the update. Right now, you will not see any BGP packet or any update packet going. It is simply resetting. Let me go to router 2 and configure BGP. See, router BGP. What autonomous system is router 2's autonomous system? 20. Neighbor. Who is the neighbor? 10 dot. Neighbor address for router 1. Remote AS is, what is the AS? 10. See, after hitting enter, I'll take you there. I'll take you there to the Wireshark. You see now. Earlier it was resetting, but now you will see 1, 2, go, finish. All right. Now let me stop this and show you from the top. Look, SYN plus ACK. So three-way handshake is successful. You see a tick mark? I did not tick mark. It does the tick by itself. You see a tick mark here. But you don't see the tick mark for this. It says it begin here, it concluded here. See, the Wireshark is very friendly. It says here the three-way handshake is successful. SYN, for this SYN, it's an ACK. For this ACK, this is a SYN. Right now, the open message, I told you in open message, I said in open message, it will send what? Router ID, AS number, and the hold time. Let me open this. See, it's an open message. You see, it is written. It says hold time, AS number, the router ID. It has taken the physical interface address as a router ID because we don't have a loopback interface. This is open message. 2 is sending open message to 1. Likewise, 1 is also sending open message. See, autonomous system 10. The router ID of router 1 is 11.11.11.11. I think there is a loopback address earlier configured. That's why it is 1.11.11.11.11. Fine. Now next, the keep alives are sent between R1 to R2, R2 to R1, and at last you see the update message. I'm opening an update message coming from router 2. Are we advertising any network? Do we advertise any network from router 2? Think and tell. Do we have any network advertising from router 2? No. So if you open the update of router 2, you will not find anything. See, router 2 is sending update to router 1. How do I know? See the source address and destination address. When I open the update message, I don't see anything, any network advertised. But when I click on the update message sent from router 1 to router 2, you see a lot of information. It shows that I'm advertising this network 111.000/8. Prefix length is /8. And it is also showing that it is originated in BGP. This IGP is not IGP protocol like OSPF. This means it is not a redistributed network. It is advertised locally using BGP's network command. Correct? No, we did not redistribute. So these are all called as attributes. AS number is 10. Next hop address, if for router 2 to reach 111, what is the next hop? Router 1's address. So these informations you can see in the update. Yep. So far what we have done is we have done eBGP. One more thing I want to show you before I move on further. What it is, between eBGP the TTL value of all the packets will be 1. Between eBGP, the time to leave of the packet will be 1. Let me open and show you. You see, open any packet. The TTL is going to be only 1. Only 1. Why? For security reason, they have designed like this. The packet of BGP should not go to somewhere and form neighbor. Then it will be like, a few days before, one of our student was asking me question. Sir, what is BGP hacked? I saw in the news, BGP is being hacked. What does that mean? BGP is being hacked. See, BGP hacking is a very big threat for the entire world. What is the meaning of BGP hack? Did you come across the news anytime? No? A week before it was there. BGP is hacked. Between ISPs, it is only the BGP routing protocol provides a route. If someone hacks BGP, what does it mean? Someone is pretending like a genuine ISP and giving you the routes. That route may not be a genuine route. It may be diverting all the packets to the attacker's country or a company or underground world, so that all the packets of a country will go through the attacker's underground. So if I am communicating from India to France, France will receive my packet, but in the middle, it goes through attacker's network. How? Because the route given to me shows the gateway as attacker's gateway. So attacker receives my packet and he forwards it to the France. So if someone will successfully negotiate BGP with your router, they can give you wrong routes and divert the packet. That happened actually last week. So to prevent that, how BGP is designed, it is designed to form neighbor only if neighbor is directly connected. That is why the TTL you saw 1. The TTL was only 1. That prevents this type of attack, BGP hacking. Usually that never happens, but somewhere, see, if you use a Huawei router, Huawei by default, only one hop only it will support, like Cisco. eBGP neighbor should be directly connected one hop. But you also have an option in Cisco as well as in Huawei as well as in every vendor. You can increase the hop. I can say in Cisco increase 2 hop so that it will try to form neighbor within 2 hop. But in Huawei, if you try to increase and if you don't say exactly how many hop, by default it will take 8 hops. What if in that 8 hop attacker is sitting? So that is how this BGP hacking might have happened. So what I have shown you and what I'm trying to show you is BGP, if it is eBGP neighbor, they need to be directly connected. How it is checked with the TTL. If R1 tries to form neighbor with eBGP neighbor with R3, it is not possible. Only when you increase the TTL value, it will be possible. By default, it is only one. But when you form IBGP neighbor, the TTL is going to be 255. So within the autonomous system, if you want to form neighbor, there is no restriction. Within the autonomous system, if you are trying to form neighbor, there is no restriction. They can form neighbor even if the neighbor is 200 hop away. Make sure they are pinging each other. It's a TCP protocol. They need to do three-way handshake, so they should ping. That's why we run OSPF or ISIS protocol within autonomous system to provide reachability to form IBGP peering. Now I'm going to configure IBGP on R2. Please pay attention to this closely. Neighbor. Before that, I want to show you, show IP route BGP. You see, you learned this route from router 1. And we also saw in the previous class, BGP is an autonomous system by autonomous system protocol. Means path vector protocol. You see, it shows the path. It shows that this network is learned from this gateway 10.12.0.1, which is the next autonomous system address. And that belong to AS 10. What is the local AS? What is the local 20? It learns from eBGP. Fine. Now let us go to router 2 and configure an IBGP. Router BGP 20. Neighbor is 10.23.0.3. Remote AS is also 20. So this is, see, the command looks similar to eBGP configuration, correct? But this and this number are same. So that tells router 2, cool buddy, it is just an IBGP. You can send TTL of 255. It says you can send TTL of 255. So what I'll do is, to show you that, I'll right click. I'll start capturing now. Alright, see, it is simply resetting between router 3 and router 2. It is resetting. See, TCP send, TCP reset, because we have not finished configuring router 3. Let me configure router 3 now. Router BGP 20, neighbor is 10.23.0.2, remote AS is 20. As soon as I say this, you will see here three-way handshake getting successful between. Wonderful, it has come already. Let us stop this. You see, the three-way handshake SYN going from router 2 to router 3. You see, router 2 to router 3. And SYN plus ACK coming from router 3 to router 2. And then acknowledgement going from router 2 to router 3. Done. After this, open message and keep alive and update. In update, you won't find, you will find from router 2, you will find the eBGP update going. You see, this is eBGP update coming from another autonomous system. What is the autonomous system? It's coming from 10. So it clearly advertises all this information. And you see the next stop is not router 2's address, it is router 1's address. Because it's an autonomous system by autonomous system routing protocol, it won't change the next stop. Router 2 will not put its own address. It will simply carry router 1's address. And now, we see here all these messages are shared between these routers. Now, okay, sorry. One thing that I want to show you is eBGP, the TTL value will be 255. You see, TTL value is 255. When we were seeing IBGP, it was 1, but here you take any BGP packet or any BGP related TCP packet, you'll see only TTL of 255. Because there is no problem in forming an IBGP neighbor, only the security is needed between eBGP. So for eBGP, the TTL is 1 by default. Hope you understood how to configure the basic BGP and how to advertise a network in BGP. One thing you need to keep in mind, the mask of the interface address must match when you advertise it. If it's a classful IP address on the interface, you no need to mention the mask keyword while you advertise. If it is not classful, then you should use the mask and match the mask of the interface address under BGP network statement while you advertise. Kindly ask me a question if you have any. Why we have to configure and how we can avoid, we will discuss that in the coming days. That is coming later. We have not covered that portion. It's coming. Yes? We advertised in R1 and we also saw R2 giving it to R3 in the Wireshark. Now I'm going to show you here. Show IPBGP. You see, you can see 111 coming from, this is R1's address and it is coming from 10 autonomous system, right? So